Hello and welcome to Chemistry Masters. In this another video of electrocyclic reaction, here we are going to discuss majorly about the ring opening and ring closing electrocyclic reaction, taking the example of 1,3 butadiene, where there will be involvement of HOMO of the molecules, as well as along with them we will be discussing that what will be the impact of thermal condition and HNU condition, and how does the rotation of the molecule, that is cone rotation and disk rotation, affect the electrocyclic opening and closing reactions. So let us move forward. In this particular video, so as we have discussed, we will be discussing the ring closing as well as ring opening reactions. So firstly we will be taking the example of ring closing electrocyclic reaction, and the example which we are discussing here is of 1,3 butadiene molecule. So we already know the structure of 1,3 butadiene molecule. It is open molecule which we have shown here so that we can close the particular structure, and we all know that, as we have seen in our earlier videos also, how does the closed structure is shown. In electrocyclic reaction we already know that the closing reaction shows you the decrement in the number of pi bond. The number of pi bond which are present here, they are 2. They will decrease to 1. While in the electrocyclic reaction, the pi bond increase by the number of 1. Here there are 3 sigma bond, while in the product, in closed reaction or in closing reaction, there are 4 sigma bonds. Now we will see that how does this ring closing electrocyclic reaction happen. So if you talk about the electrocyclic reaction happening in any molecule, one of the major component in them is that the reaction can happen in the presence of light or maybe in presence of heat. And as we have seen in the earlier videos, that in condition of light and in the condition of heat, the electron filling in 1,3 butadiene molecule is of different kind, and due to that what happened, the HOMO and the LUMO of that 1,3 butadiene is also different. So that we can see here again, because the concept of HOMO is very much important for the ring closing as well as ring opening electrocyclic reaction. So before understanding how does the ring will get closed, we will first see that what is HOMO in case of thermal condition and what is HOMO in case of HNU condition. So we already know that in 1,3 butadiene there are 4 molecular orbitals which are arranged like this, which we have shown here, and the reaction can happen in HNU condition and thermal condition both, as well as the electron filling in HNU condition and thermal condition are different from each other. So firstly we will be seeing it in terms of thermal condition. So in thermal condition what will happen? The electrons will be filled like this. We already know that in a particular molecular orbital the maximum of 2 electrons can be filled, and they are filled according to the energy level. The lower energy level are filled first and then the higher energy level are filled. So in molecular orbital of 1,3 butadiene there are overall 4 electrons, which in thermal condition or ground state condition will be filled like this. The 2 electrons will be filled in psi 1 molecular orbital and psi 2 molecular orbital, while psi 3 star and psi 4 star molecular orbital will remain unfilled. So this psi 2 molecular orbital will be our HOMO, while psi 3 star molecular orbital will be LUMO in thermal condition for 1,3 butadiene molecule. Now when we talk about the HNU condition or light condition, in that what happened, we know that the electron get excited due to the irradiation of the light and it jumps to the next higher energy level, and the electrons which are jumping, they are generally jumped from that molecular orbital which is higher in energy. So out of these 2 molecular orbitals where the electron has been filled, the psi 2 molecular orbital will be allowing its electron to jump to the psi 3 star molecular orbital. so that the psi3 star will become HOMO and psi4 star will become LUMO for this particular condition. Now this HOMO in thermal condition and this HOMO in HNU condition is responsible for all the electrocyclic reaction. Or you can say that the ring closing and ring opening reaction actually depends upon the HOMO condition of thermal as well as HNU condition. So we will take both of them one by one. If you see in thermal condition, the HOMO in that the symmetry which is present is of C2 type. So here it is C2 symmetry in this molecule. So that will be used here for showing the ring closing condition of the molecule. So now we will see that in thermal condition how does the reaction will take place. We already have seen earlier that in thermal condition the psi2 is our HOMO and it is having a C2 type of symmetry. Now we will see that how does the reaction will take place or how does the ring closing will happen out here. So whenever any reaction happen, it is very much important that two same type of lobes or same type of orbital arrangement should be there. If two different type of orbitals are joining to each other, in that condition what will happen, the reaction will not be feasible or it will be symmetrically not allowed. So in this particular condition there is C2 symmetry. So we already have discussed in our earlier video, if you see that, the link is given in the description also, that whenever there will be C2 symmetry in the molecule will always undergo cone rotation. So what will happen here? This particular orbital will move on this side and this on this side. Or you can say the same type of rotation or the rotation on the same direction will be there. So here the both of the orbital will move on the same direction, so that what will happen, the positive lobe will go inwards like this and this negative lobe will go outside while the positive lobe will come inside, so that interaction or bonding interaction happen between the two lobes or the two orbitals which are shown here, and they will do what? They will make the cyclic structure or ring closing of this particular molecule. So always remember that whenever there is C2 symmetry in the molecule, there will be always cone rotation to give you the symmetry allowed closed reaction. Now taking the another condition where there is light condition, where we are providing the light to the molecule, and due to that what happened, the electron from the ground state HOMO get jumped to the next level to give you excited HOMO. So here in HNU condition, psi3 star will be our HOMO, and you can see that here in the molecule there is mirror symmetry present. So we already have said that in electrocyclic reaction, HOMO is the responsible for the reaction. So now we will take the excited state HOMO, that is psi3, which is having M symmetry in it. When there is M symmetry, now again what we have to do for feasible reaction or for symmetry allowed reaction, we have to bring same type of lobes to interact with each other. In this case what will happen, if I move this particular orbital towards my right hand side, in that case for the symmetry I have to bring this second orbital towards my left hand side, so that these two same type of orbital can interact to each other to give you symmetry allowed reaction. So what will happen when these two lobes are moved in opposite direction to each other? In that case the interaction happens. This positive lobe will go inside and the negative lobe will go outside. Here for the right hand side orbital, the positive lobe will go inside and the negative lobe will come outside to give you the bonding type of interaction. And when this bonding type of interaction happen, in that case the reaction get complete or the cyclic structure is formed. So here the reaction which happen, it is of this mode, means for 1,3 butadiene molecule in HNU conditions, psi3 star will be HOMO and this rotation will be required by the molecule to close it in a symmetric form to give you cyclic reaction. So from these two examples we have understood that for thermal condition there will be requirement of cone rotation, while for HNU condition there is requirement of this rotation for making the molecule to undergo ring closing electrocyclic reaction. Now we will be taking some more examples where we are having some substitution at the two ends of 1,3 butadiene structure. So it is somewhat like this, that this is our 1,3 butadiene structure which is having some substitution like this. Maybe this could be the structure or maybe this could be the structure. So now we will see that whenever the ring closing happens in thermal condition or HNU condition, what will happen with these substitution, whether they will go in cis form or whether they will go in trans form. Now in the first structure which has been shown to you, in that you can see that the two orbitals which has been shown here, they are in C2 symmetry. Now we have to close the ring, and we know that in thermal condition if you want to cyclize the molecule, we have to rotate them cone wise, or means you can say that they would be rotated in the same direction. So when they will be rotated in the same direction, the two lobes, they will interact with each other, and now we will see that what will happen with these particular substitutions also. So as it is going towards your right hand side, it will also go in the same direction, means this CS3 or this methyl species will go up, and similarly here also this CS3 will go up. Means what will happen, both of the CS3 will go in the same direction, means both of the methyl group will be remaining in the cis form. Now if these CS3 are arranged away from each other, in that case again there is thermal condition. We all know that in thermal condition the psi2 is our HOMO, where the C2 symmetry is present in the molecule, and we all know that in C2 symmetry there is requirement of cone rotation so that they both will be moving in the same direction. Along with them, what will happen, these CS3 will also move. So as it is moving in this direction towards our right hand side, this CS3 will go this side. So what will happen, the CS3 which is present with the first orbital will go up during the ring closing reaction, while this CS which has been shown with the second orbital, it will go downwards, so that a trans type of arrangement will be observed. Now we will see the same thing with these attachment in HNU condition. So already we all know that in HNU condition the psi3 star is our HOMO, and in that particular molecular orbital M symmetry is preserved. So if there is M symmetry, in that case, to bring these two same type of lobes to interact with each other, we are required to move these two orbitals in disk formation or disk stereochemistry. So what will happen, if it is going right side, it will go towards left side and vice versa. So if it is going towards right side, it will go upward, and if it is going towards its left side, again this CS3 will go downwards. So what will happen, in HNU condition there will be a trans type of arrangement between these two substitutions. While here also you can see in HNU condition again there is mirror symmetry, while these CS3 or the methyl group which are present here, they are far away from each other. So for ring closing reaction, we already have said that there is a requirement of this rotation in the molecule. That means one of the orbital will going toward the right side, another will be going toward the left side. Along with them, these species which are substituent, they will also move in the same direction where these orbital are moving, and you will see that these two substituent, they are moving in the same direction to give you the cis type of arrangement. So this is how the ring closing reaction happens in the case of 1,3 butadiene molecule. Now we will discuss that how does the ring opening electrocyclic reaction will be carried on. So here we will be taking the example of cyclobutene molecule, which in excited state or may in thermal state will get converted into 1,3 butadiene molecule. Now here we will see that how does the ring opening take place, or how does the orbital which has made the ring closed, they will again get open. So if you talk about this sigma bond which has been created, which is responsible for the ring closing, that particular molecular orbital is formed due to the interaction between the two terminal orbitals. These two terminal orbitals, they overlap to each other and they form this sigma bond out here. Now if we have to convert this cyclic structure to non-cyclic structure, or ring opening reaction is to be carried, in that case we have to again make these two orbital apart from each other. We have to carry these two orbital to their original places. Now this breaking of this sigma bond or ring opening reaction can be carried in thermal as well as in HNU condition. So we will see that how this thermal and HNU condition reaction will be carried and how the bond will be broken and what will be the symmetry in the open chain structure. First we talk about the thermal condition and then we will take the HNU condition. So in thermal condition, here you can see that there is formation of a sigma bond due to the overlapping of these particular two orbitals. As this sigma bond is present here, now we have to open this bond, or we have to move these two orbital apart. Now one very much important thing which already we have discussed earlier also, that in electrocyclic reaction, HOMO is of major importance. Whenever the ring is getting closed, the HOMO of thermal condition or the HOMO of HNU condition will be taken in consideration. And similarly, whenever the ring is getting opened, in that condition also, when it get open, it get changed into the HOMO of thermal or HNU condition. That means whenever we are opening the chain, if you are carrying the reaction in thermal condition, the opened structure will be having the symmetry of the HOMO of this thermal state. Means when the reaction will carried on, the ring will get open, the symmetry of side 2 molecular orbital will be obtained. And similarly, when we are carrying the ring opening reaction in presence of light, the symmetry of this HOMO, that is side 3 star, will be observed in the product. So if we carry the reaction in thermal condition, we should be getting the product as side 2, that is the HOMO in thermal condition. So here you can see that the two terminal orbitals which are present here, they are having a C2 type of symmetry. You can see this one and these two field orbitals, they are on the opposite direction. That's why there is C2 symmetry. So this C2 symmetry should be obtained whenever we are opening the cyclic structure of cyclobutene into open structure, that is 1,3 butadiene in thermal condition. So here you can see that this cyclic structure has been changed into open structure where we have shown two terminal orbitals only. So here what happened, this is your side 2 orbital which is HOMO in thermal condition. Now we have to see that how we can get this C2 symmetry in thermal condition, or how we will rotate these two orbital of sigma bond to get this arrangement. So for that, if you see here, the positive lobe is on the upper side, while for this particular orbital the positive lobe is on the lower side. So I have to take this positive lobe towards upside and this positive lobe towards the downside. So how I can do? So if I move this orbital towards my left hand side, so this orbital will go towards upside, and then if I carry this orbital toward downside, if I put some pressure over here and if I take it on this side, what will happen? This positive lobe will come downwards. So if you see again, this movement is from my left hand side, or you can say both of the movement are anti-clockwise. So that's why you can say when I will be carrying cone rotation of these two orbitals which has made the sigma bond, they provide me the HOMO of thermal condition, that is side 2 molecular orbital, which is having C2 symmetry, which we have seen earlier. Similarly, if you talk about HNU condition, in HNU conditions, the HOMO for 1,3 butadiene, that is to be our product, is psi 3 star, where the terminal orbitals are present in such a way that the mirror symmetry is present. So we have to do what? When we are going to open this cyclic structure in light condition, we should be getting mirror image of the orbital. So these two terminal orbitals which we have shown here, they, you can see, are in the mirror symmetry, and this is HOMO in HNU condition, and this is our psi 3 star molecular orbital. So now we have to see that how I will be moving these orbital so that I can get this mirror image. So for that, this first orbital is towards upper side, or the positive lobe is towards upper side. So I will be moving it towards my left hand side, or anti-clockwise direction movement will be there. While the another positive lobe which is on this orbital is there, it is again towards upper side. So I have to bring this lobe again towards the upside. That's why I have to move it on this side, that is towards my right hand side, or you can say clockwise direction movement. So these two are moving towards opposite direction. That's why I can say that there is need of a disk rotation, so that I will be getting mirror symmetry for this particular 1,3 butadiene molecular orbital. So this is how we have seen that in case of ring opening electrocyclic reaction, the molecule will get changed into non-cyclic structure, and for that the HOMO of the non-cyclic structure will be the most important component. We have to re-get the arrangement of orbital of HOMO for HNU conditions as well as for the heat condition, and for that we have to carry on cone rotation and disk rotation respectively in case of thermal and HNU conditions. So this particular concept also tells you that whether it is a ring closing reaction or whether it is a ring opening reaction, in the reactant and in the product, the symmetry of the molecule remains preserved, and for whatever condition is allowed for ring closing reaction, that is whether it is a cone rotation or whether it is a disk rotation, the same type of symmetry, the same type of rotation is also required for opening of the reaction also. Now we will be seeing some of the example in which ring opening reaction will be carried on in those molecule where there is substitution present. So here again we have taken the same molecule which we have gained after the closing of the reaction. Now we are going to open them. So in thermal condition, if we are going to open the molecule, for that we have to remember that what is the HOMO. So we all know that the side 2 is the HOMO in case of thermal condition of 1,3 butadiene, where there is presence of C2 symmetry. So in the molecule also you require C2 symmetry, so that you will be obtaining this C2 type of arrangement. C2 type of arrangement is present here. So for that what we have to do, we have to rotate the molecule in such a way so that the two lobes will be going in opposite direction to each other. So what we will do, we will rotate it in this way so that this red lobe will go up, and here we will be rotating it in this direction so that this red lobe will be coming on the lower side, so to give you this structure. So you can say a cone type of rotation is required, and whenever this rotation happens, these two methyl group, they will be again going according to them. So it will be as it is going towards this direction.
So this CH3 will also go this side, so it will come on this direction. You can see CH3 here. So as this is going towards lower side, so this CH3 will come inside in this way. So similarly, you can say that this is cis type of arrangement in open chain structure. So here when these CH3 are in the trans, so again this is your thermal condition. In thermal condition, side 2 is our HOMO and C2 is the symmetry which should be there in the product. You can see here the C2 is the symmetry present here. So in this case, when it is moving on this direction, this red lobe will go up, and when it is moving in this direction, you can see that this lobe is going towards the downside. So you can see that overall what is happening, it is moving like this, and already it is moving on the same direction. So this is a cone rotation again, and during the cone rotation the CH3 will go according to them. So along with the movement on this side, this CH3 will come here, and along with this movement the CH3 will go this side. So this is a trans type of arrangement in the case of open molecule. Now we will take the same two molecule in terms of light condition. Excited form, we already know that psi 3 star is our HOMO, and in psi 3 star mirror is the symmetry. Means the two lobes which are present here of same kind, they will be on the same side. So that can be happen when these two lobes are moving in opposite direction to each other, so that you will be getting these two structures. So this is going towards your left hand side and this one is going towards your right hand side. So just opposite to each other, you can see. So it is going like this and it is going like this. So opposite to each other, so that you will be getting the two lobes on the same side. And that's why you can say that in this case this rotation is required, and along with the movement of these lobes, these CH3 will also move in this direction accordingly. And what will happen here, the two CH3 will face towards same side. This is again the cis type of arrangement in open molecule. So here again you are having in the last structure the HNU condition. Psi 3 star will be HOMO and mirror symmetry is always there. So again you require the two same type of lobe on the same side. For that again we have to rotate them in such a way so that there is a presence of disk rotation, and along with this disk rotation these CH3 group will also move, and they will move in such a way that these two CH3 will go far away from each other like this. So there is a condition of trans. So here we have understood that the ring opening reaction and ring closing reaction both can happen in electrocyclic reactions. In both of them, whether it is reactant or whether it is product, the symmetry is always same, and to get that symmetry the rotation is always of same kind. So in thermal condition there will be always C2 symmetry whether it is reactant or product, and to get that there will be always cone rotation, and in HNU condition the symmetry will be always M symmetry, and to get that there will be always requirement of disk rotation. And another thing which is very much important out here is that whether it is ring opening reaction or ring closing reaction, if there is a ring closing reaction, HOMO of thermal condition or HOMO of HNU condition will be responsible for ring opening. And if you want to open the ring, after opening the ring there should be always generation of HOMO of thermal condition and HOMO of HNU conditions. So hope this video would have cleared all the concept of ring opening and ring closing electrocyclic reaction in case of 1,3 butadiene. It also would have cleared the concept of HOMO and LUMO required for electrocyclic reaction and how does the ring opening and ring closing reaction happen with the disk rotation and cone rotation in electrocyclic reaction. So in our next lecture, we will be bringing the ring opening and closing reaction for 1, 3, 5 hexatriene molecule. There also we will discuss that how does the ring opening reaction in thermal and HNU condition along with the disk rotation and HNU rotation happens. So thank you for watching our video and keep liking us.